Lesson on waves. We start our discussion of waves by talking about mechanical waves. All waves carry energy, and these waves are produced by a disturbance in a medium. What is a medium? Well, a medium is the material the wave moves through. For these waves here, this person is creating a disturbance in the water and thus producing waves in the water. Here we have a fighter jet producing a disturbance in the air, where air is the medium for these sound waves. Here we have a slinky, which provides the medium as a spring for waves down the slinky. Now, as we talk about waves moving, we say waves propagate, or there's a propagation. That's just a fancy word for the motion of the wave. There are two basic types of waves, the first type being transverse. Transverse is where the disturbance creating the wave is perpendicular to the direction of propagation, meaning we disturb this slinky this way and the waves move in this direction. As we can see in this transverse wave, there are many characteristics. The top part of the wave is called the crest, and the bottom part of the wave is called a trough. The second type of wave is a longitudinal wave. This is where the disturbance is in the same direction as the direction of propagation. That is, on this slinky, the disturbance is in this direction. I push on the slinky this way, and the wave moves in the same direction. Since we push on the slinky, we're going to compress some of the coils together, and this area will be called a compression. If some coils are compressed, there's going to be other areas where the coils are further apart. These areas are called rarefactions. So a transverse wave has crests and troughs, while a longitudinal wave has compressions and rarefactions. Characteristics of waves. Let's look at a transverse wave here just to learn the various characteristics. The frequency, represented by the letter F, is simply the number of waves per second, and the units of frequency are hertz, often abbreviated Hz. The period, represented by capital letter T, is the number of seconds per wave, and measured in seconds. The wavelength, symbolized by this Greek letter lambda, is the horizontal distance from crest to crest, and that is measured in meters. Here we can see the wavelength from crest to crest of our transverse wave. The amplitude, represented by the capital letter A, is half the vertical wave height and measured in meters. So here we can see the full wave height, but half of that wave height is the amplitude. And lastly, every wave has a velocity, or speed of the wave, measured in meters per second. We can look at the characteristics of waves to tell them apart. Let's compare two waves here. Let's look at this blue wave, which has a low frequency and thus not making many crests per second. Here is a higher frequency red wave. So here you can see our wave is much more frequent, many more waves per second. And you can see these two waves look different, especially if we look at the wavelength. If we look at the low frequency wave, the distance from crest to crest is very far apart. That is, these waves have a longer wavelength. If we look at the higher frequency waves here, if we look at the distance from crest to crest, we can see that that distance is much smaller. So here we have a much smaller wavelength. And assuming these waves travel at the same speed, say the same velocity in this direction for both, we can conclude that these low frequency waves have a much larger wavelength and higher frequency waves have a smaller wavelength. Mathematics of waves. As you saw the definition of frequency and period, you may have seen that they're the inverse of each other. That is, the frequency is the number of waves per time, whereas the period is the amount of time for one wave. Thus, we can write these as the inverses of each other, where frequency is the inverse of the period, and the period is the inverse of the frequency. So if you know one of these, you can find the other. We can calculate the velocity of a wave using our old velocity equals distance over time, but we can also look at the characteristics of a wave. That is, the velocity of a wave, well, the distance one wave travels is called the wavelength. The amount of time for one wave is called the period. So you could also calculate the velocity of a wave by taking the wavelength divided by the period. However, we can also note velocity is equal to the frequency times the wavelength. That is, since 1 over the period is frequency, we can put that in and get the wave equation, which is velocity equals frequency times wavelength. And this will be the most often used way to determine the velocity of a wave. Thank you for watching, and see you in class.